thing that we want to talk about is sort of comparing and contrast these two key vocab words that we have are ratio and proportion, okay? Now, I'm pretty sure that you've heard these words before, so I just want to know whatever you think right now, spit it out. Do you got anything ratio versus proportion? How are they similar? How are they different? Anything like that that we could start off the day with? Yeah, what do you got? Yeah, a ratio is a comparison. Good, I like that. What else you got? Yeah? Ratio, yeah. So a ratio is, this uses division to compare two numbers, right? Two quantities. Oops. So a ratio uses division to compare two quantities. Okay, how is that similar or different from a proportion then? Anybody there? So a proportion uses, so a proportion is a statement that sets two ratios equal to each other. So a ratio uses division to compare two quantities, and a proportion is a statement that sets two ratios equal to each other, right? It says that they are equivalent. So let's practice with this. Take a look around the room, all right? Let's create a ratio. Take a look around the room. What's the ratio of guys to girls? Let's count. Oh, 22. Okay. Okay, so the ratio of guys to girls, right, in our classroom, we just counted that guys there are 22. And then how many girls are there? If you're a girl, raise your hand. If you're a girl, raise your hand. So we can count them up real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. Woo, man, check that out. 22 to 9. That should tell you something. That should tell you something out there. Okay, so check it out. We've just created a ratio of guys to girls. Okay, that's a ratio, right? A proportion would be taking that ratio, 22 over 9, and setting it equal to something. Say like x over 18, right? Now all of a sudden you have a proportion. You guys got it? See the difference between the two things? Yeah, cool. Okay, there's a couple of ways that we can represent a ratio. We can represent it in a variety of ways. There's 3 ways here. You can either say something like this. You can say A to B. Like we could say guys to girls, right? We could put the actual word to between them. We could say it like this. We could say A dot dot to B, right? A colon there. A dot dot to B. Or we could do the most generic way, which is A divided by B. Most of the time, ladies and gentlemen, we're going to be using this one, okay? But any one of those 3 ways is okay to write a ratio. Does that make sense? You can pick any one of those 3 ways that you want to do it. I'm going to, the next example that we're going to do, I'm going to call this the cell phone example. So right here for the second box, call it the cell phone example. Okay, the cell phone example. I'm going to read to you a problem. I want you to listen for the key information. Okay, you guys ready to go? Yeah? Okay, here we go. It says, a person makes 6 long... I don't do that. Okay, back to my little story here. Listen up. A person makes 6 long-distance phone calls and 15 local calls in 1 month. I'll read it again. It's a short little story. A person makes 6 long-distance calls and 15 local calls in 1 month. Okay, somebody give me a piece of information that is useful from that little story. Yes, what do you got? We had 15 local calls. I gotcha. Give me something else that's useful. Yes, sir. We had 6 long-distance calls. Long-distance calls. Anybody ever make a long-distance call? Yeah?
I do.
Yeah? Good. What else you got?
Oh, no.
Oh. And all of this was how long? What was the time frame that they did it in? 1 month. Good. Okay, I'm going to give you a task right now. I would like you to find the ratio of long distance calls to local calls. So find the ratio of long distance to local. All right, Dalton, what do you got, boss? What's the ratio of long distance calls to local calls? What would it be? He says 15 to 6. Is that right? We want long distance to local. So how many long distance calls were made? So we're making 6 over 15. So the ratio should be 6 to 15. Now, can we simplify that ratio? Yeah, why? We always want to keep our ratios in simplest form. So I'm going to divide each one by what number, you guys? By 3. Very good. So that gives me 2 divided by 5. Very good. So the ratio that we want in the end is 2/5. Okay, here's part B for you. Ramsey, this one's yours. What is the ratio of local to long distance? All right, what's the ratio of local to long? Ramsey, what'd you get?
I got 15 over 6.
He says you got 15 over 6, and then he simplified the ratio to get 2 over... sorry. That's not what you got. What'd you get? 5 over 2. Good. So we have a ratio of local to long distance would be 5 over 2. Okay, here's the challenge question. Ready? Here's the challenge question, part C. What's the ratio of long distance to total? Ooh. What's the ratio of long distance calls? All right, Sergio. Sergio, tell us, what'd you get? What's the ratio of long distance to total, please? What'd you come up with?
2 over 7.
Yeah, how did you get 2 over 7? That's the right answer. How'd you get that?
The long distance cars is 6.
Yep, 6, good.
Over the total, 15 plus 6 is 21.
Yeah, 15 plus 6, right? That gives you 6 over 21. And that gives you the 2 over 7. Nicely done. Very nicely done. Okay. All right, you guys feeling pretty good about that section?
Alright, decent.
Yeah, all right, decent. Good. That's good. All right, here we go. Okay, we're going to solve a proportion. Now remember, what's the difference between a proportion and a ratio? Proportion's going to have what in it? It's going to have an equal sign. You got it. Okay, it's going to have an equal sign. So we're going to solve this proportion. Say this. Y divided by 15. Now, is that a ratio or is that a proportion that I just written up there? It's a ratio. Good. All of a sudden, I'm going to make it a proportion because I'm going to set it equal to something else. 3 over 5. Now, there's a couple of ways that you can do this problem. There are a couple of ways you can do it. Does anyone know? I can think of 3 ways. Can anyone share one of their ways? Yeah, go ahead. What do you got?
Just 3y equals 5 plus 8. And then divide by 3.
How'd you get the 3y part? Yeah, when you say cross multiply, you have to cross multiply like this, right? How many of you have you ever seen the cross multiply way? Raise your hands. Let the record show everybody in the room's hand is up. Good. Well, let's go ahead and do it this way, okay? Here we go. If I cross multiply, what is 3 times 15? Yeah, 45 is equal to 5 times y is how much? 5y. Good. Now, I'm going to divide by 5 on both sides. Divide by 5. So that tells me that y is going to be how much? 9. Good. That's one way to do it. Okay? Here's one way. Here's the first way. Is there another way we could do this problem? There is. Does anybody see it? The fast, easy way to do it? Okay, let's make some sense of this. Is it okay if I write this problem down again over here? Y over 15 equals 3 over 5. Okay, now, let's make this connection here. If I take 5, what number do I multiply 5 to get to 15? I multiply by 3. So that means I have to take this number and multiply by 3 to get y. What would that number be? What's 3 times 3? Oh my gosh. There you go. Are those the same? They are the same. It doesn't always work that way. They have to be like sort of nice, easy numbers to work with you, right? But that is what the proportion is telling you. It's representing the ratio in a different number set. So we can definitely solve proportions like that. So there's two different ways to solve those proportions. Let's solve another one together. And that's going to be this one. Let's do 9 divided by 4 is equal to x divided by 28. Let's solve this proportion. 9 divided by 4 is equal to x over 28. Have a seat, have a seat, have a seat. Behind you. All right. Let's see here. Does anybody see something clever we could do? 9 over 4 has to be the same thing as what over 28? So we're looking for an equivalent ratio for something over 28. Ask yourself this. 4 times what gives you 28? 4 times 7? Is that 28? Yes, it is. So if we multiply by 7, we get 28. So that means that if I had to do this, I had to multiply this one by 7. What would that give me? So x would have to be 63. Okay, let's check that by cross multiplying. 4x is equal to, what's 9 times 28? Yes, we know it's a number, but the important question is which number? That's still not getting us any closer to the answer. Okay, well, if we don't know, here's what we do. 28 times 9. 262 or 252? Okay, well, here we go. What's 9 times 8, everybody? Come on, help me out. How much? 72. So 18 and 7 is how much? 252, is that right? Okay, so 252. Now we divide by 4. We divide by 4. So we take 252, and we need to divide by 4. How many times is 4 going to 25? 6 times, right? 6 times 4 is 24. Subtract, bring down the 1, bring down the 12. Hey, check it out. 63. Is that what we got up there? Same thing, right? Because it's an equal proportion, equal ratio. Look, I got an applause in the back. I love it. I got an applause in the back. All right. Okay, here's the story. Listen to the story. See if you can collect some important information. The story says this. An empty swimming pool is being filled with water. After 5 minutes, the pool has 400 gallons of water. If the pool has a volume of 11,200 gallons, how long does it take to fill the empty pool? Okay, I'll read it again to you. Read it again. Listen for the important information. I'm going to ask you. An empty swimming pool is being filled with water. Get the picture in your head. After 5 minutes, the pool has 400 gallons of water. If the pool has a volume of 11,200 gallons, how long does the pool take to fill? Okay, important information, so we'll call this the pool problem. Okay, anybody get any important information in that story that I just read to you? Yeah, what'd you get?
It takes 400 gallons.
Okay, so in 5 minutes, I know that I have 400 gallons. Okay, good. Anything else in there? There's one more really important piece. What is it? The total volume, which was what? Good. So if I'm going to set up a proportion, where does the gallons go? On the top or the bottom? Andres, where does it go? On top or the bottom? Yes, the question is, if I know there are 11,200 gallons total, does it go on the top or the bottom? Why the bottom? Because the minutes are on the top and the gallons are on, and we're going to keep our proportions equal. Good. So this is 11,200. Awesome. So what are we looking for? What are we looking for? How long? So what do you guys want to call that? X. All right. All right. What is the method we're going to use to solve this proportion? Cross multiply. Good. So help me out. What is 400 times x? That's just 400x, right? What is 5 times 11,200? 56,000. Very good. How do I figure out what x is? I divide by 400. Now, you do realize, ladies and gentlemen, you can cross out zeros. Is that true? Yes. So we now have 560 all divided by 4. How many times is 4 going to 5? Once. Gives you a 4. Subtract brings you 1. Bring the 6 down. How many times is 4 going to 16? 4 times. That's 16. Bring the 0 down. Woohoo! We have 140 minutes. How many hours is that? 2 hours and 20 minutes. There you go.